Good morning, all.
Good morning, sir.
Good morning. Am I audible?
Yes, sir, you are audible.
Okay. So I welcome you all in this 60-second lecture of data structures and algorithm. We are in unit number 5. We are learning about the graphs. In last lecture, we have started that unit, and we have started with the basic terminology of the graph. So let me share my screen, and we should have a small recap of what we have done yesterday, and then we will start the next terms that we need to know before moving into the deep of graph. So is my screen visible to all now?
Yes, sir, your screen is
Yes,
visible.
sir.
Okay. So we have started with some discussion with some applications of the graphs. Then we learn the definitions of simple graph and directed graph. We have also learned about the concept of ordered pair and unordered pair. Okay. Then we see some examples of the graphs also, how where we need to use directed graph and where we need to use undirected graph. We start the terminology by loop, then mixed graph, simple graph. Can anybody tell me what could be a mixed graph?
Sir, a combination of directed and undirected graph.
Very good. A
Yes,
combination
sir.
in
Of
which both types
directed
of
and
the in which
redirected graph.
both type of the edges are there. Undirected edges and directed edges are there. Okay. Now, can anybody tell me what anybody else can tell me what could be a parallel edges in the graph?
They connect through same nodes and follow the same direction, or uh, they are called uh, parallel graph, like as
What
A to
which
B.
what type of the graph they called in which we have multiple edges? That particular graph is called
Parallel graph.
no. But that particular type of the graph is called. Anybody else can tell me what that
Multi-graph.
multigraph.
Multi-graph.
Very good. Multigraph. Okay. The edges between the same vertices, if there are multiple edges, then that particular edges are known as parallel, and otherwise, and particular graph is called multigraph. Okay. Adjacent and neighbors, it means keep two vertices are adjacent if they are connected by a edge directly. Okay. And they particular
तो सर
nodes are called
पैरेलल ग्राफ क्या
AND
होता
graph.
है?
मैंने बताया ही नहीं बेटा कोई पैरेलल ग्राफ.
नहीं सर, आपने अभी पूछा ना कि पैरेलल ग्राफ.
मैंने कहाँ पूछा? मैंने पूछा पैरेलल एजेस क्या होती हैं बेटा.
अच्छा, पैरेलल एजेस.
आप ध्यान से सुनते नहीं हो बेटा. डिग्री.
Sorry, sir.
Degree of the vertices means degree of a vertex means number of edges that are incidenting on that vertex. If this is for undirected graph we are talking about. The degree of a vertex is the number of edges that are incidenting on that particular vertex, and in that we will consider the loop as twice. Okay. And regular graph is called, when the graph is called regular,
When each vertex of the graph is having the same degree.
good. Okay. So now we are now can anybody tell me what could be a vertex of degree 0 called?
Null
Isolated.
graph.
Isolated vertex. Very good. Or what the degree? What if the degree of vertex is 1?
Pendant.
Pendant.
Vertex. Okay. Pendant vertex. Okay. So we have also seen some examples where we have calculated the degrees and the relationship between the degree and the number of edges in that graph. Okay. So we found that in undirected graph we always have number of edges is equals to half of the total degree, or vice versa. Number of total degree of the graph will be equals to the twice of the number of edges that we have seen. Okay. Now we are moving on to the degree definition with the directed graph. Okay. So when UE is an edge of the graph with the directed edge. Directed edge means ki we have we have an edge from U to V. Okay. Directed edge का क्या मतलब होता है? Anybody can tell me? Direction is there now. Okay. So direction is there. It means ki from suppose V
to C.
U to V, we have a specific direction. Okay. Now in this specific edge, we will call U as a starting point and V as a ending point. Now new terms are there actually. Okay. In the case of direction, we need to call the vertex from where the direction is starting is called start vertex, and the edge is ending, that the vertex is known as ending vertex. Both are still adjacent to each other. Okay. Now initial vertex or terminal vertex, these are also the terms that we can say for use for U and V. Okay. Now the initial vertex and the terminal vertex of the loop are same. Definitely, if we have a loop on that particular edge, directed edge, so it is also possible. Say this is an vertex, so this kind of a loop, for that initial
Sir.
vertex and the ending vertex is same. Yeah, yes.
सर हम इनिशियल वर्टेक्स का वो डायरेक्शन का स्टार्टिंग पॉइंट भी कह सकते हैं, जैसे यहाँ पर V और V टू U है, यहाँ पर U स्टार्टिंग वर्टेक्स है और V है टर्मिनल वर्टेक्स एंडिंग।
यही लिखा हुआ है बेटा स्लाइड्स में, यही लिखा हुआ है। आई थिंक आपको स्लाइड्स विजिबल नहीं है क्या?
यस सर है ना,
देन यही तो लिखा हुआ है बेटा स्लाइड्स में,
टर्मिनल वर्टेक्स।
आप बीच में डिस्टर्ब क्यों कर रहे हो बेटा?
नहीं सर यहाँ पर वो कह रहा था ना मैं कि
नहीं विजिबल नहीं है स्लाइड आपको क्या?
नहीं सर विजिबल है।
तो फिर आप बीच में डिस्टर्ब क्यों कर रहे हो?
ओके सर अब नहीं पूछूंगा।
बेटा लिखा हुआ है, पूछो ना, जब कुछ समझ में नहीं आए तो पूछो। दैट इज ऑलरेडी ऑन टू योर स्क्रीन। इफ यू आर नॉट एबल टू सी योर स्क्रीन देन टेल मी।
नहीं सर मुझे टर्मिनल वगैरह इससे समझ में नहीं आ रहा था ना, तो मैंने सोचा कि एंडिंग और स्टार्टिंग पॉइंट हो सकते हैं।
वो तो मैंने बोला भी था पहले, मैंने इस लाइन से पहले यही बोला था कि दे आर नोन एज स्टार्टिंग वर्टेक्स एंड एंडिंग वर्टेक्स। क्लास में यही बोला था बेटा। कैन एनीबडी टेल मी before showing this line I have used the terms starting vertex for U and ending vertex for V? Yes or no?
Yes sir.
Yes sir.
So बच्चे मैंने वही बोला था और आप सुन भी नहीं रहे हो शायद और देख भी नहीं रहे हो। आई थिंक
नहीं सर मैं इतना खो जाता हूँ कि
तो फिर आप बेटा मैं रिक्वेस्ट डिस्टर्ब मत करो आप।
ओके सर।
आप या तो ध्यान से सुनो, ध्यान से पढ़ो, ध्यान से देखो क्या लिखा हुआ है स्लाइड्स में। अब आपने डिस्टर्ब किया, बीच में 2 मिनट खराब हुए फालतू।
सॉरी सर।
बच्चे मैंने वही टर्म्स यूज कर रहा हूँ। आप मैं बहुत तेज भी नहीं बोल रहा हूँ। आई थिंक मैं बहुत धीरे धीरे ही बोलता हूँ। मेरी स्पीड ज्यादा तेज तो नहीं है स्टूडेंट्स?
No sir.
तो प्लीज बी कंसंट्रेट फर्स्ट। अपने संग बच्चे 60 बच्चे और पढ़ रहे हैं। थोड़ा पढ़ो, सुनो, ध्यान से मन लगा के बैठो, है ना। जहां डाउट हो एक बार स्लाइड खत्म होने पर फिर रोक के मुझसे पूछ लो, ठीक है? डाउट पूछने में कोई प्रॉब्लम नहीं है। आई अप्रिशिएट ऑलवेज जो भी डाउट पूछता है, तो मैं कभी किसी को मना नहीं किया, लेकिन अननेसेसरीली मत पूछो बेटा।
ओके सर आई विल।
So initial vertex and terminal vertex for the loop will be same. Starting vertex and ending vertex for the loop will be same. In this figure you are observing that for V we have a loop. So for that loop V starting and ending vertex are same in that case. Okay. Now degree. Okay. So degree for the direction of, in the case of direction. Now tell me, I have I think discussed yesterday also. In this case we will have 2 terms. One is in degree and one is out degree. Look at that U and V. Okay, from where the out edge is outgoing, you see that
U से
from U it is outgoing and for V it is incoming. So that edge will also again in that case works for both the vertices. Okay, like in the case of simple edge we have seen, simple graph we have seen, edge contributes a degree in two vertices. Similarly, here it also contributes in the degree of both the vertices. But in this case, we will use some other terms, that is in degree and out degree. For the edge in which it is incoming, it will contribute as an in degree, and for the vertex, it is outgoing, it will be contributing as an out degree. Okay. So in degree will be represented by this term degree minus v. Okay, and out degree will be represented by degree plus v. Okay, you need to take care of that thing. Okay, in a graph with the directed edges, the in degree of a vertex v will be denoted by this is the number of edges which are with v as their terminal vertex. Is it okay? And the out degree of the vertex v denoted by degree plus v is the number of edges which with v as their initial vertex. तो जहां से initiate हो रही है, for that it is out degree, क्योंकि वहां से वो बाहर जा रही है. You can see that here. From u it is going outside, and for v it is going inside. Okay. Now question is, how does adding a loop to the vertex changes the in degree and the out degree of that vertex? Can anybody tell me? Suppose again taking the same example. This is v, and a loop is there. So how the loop will contribute for v? Is it out degree or is it in
degree and out
degree?
degree will be same for the particular vertex, because it
will be
coming out
contributing
from
for
the same
both.
vertex and going in the same vertex.
Very good. So it will be contributing in both, as both. Again, in that case, it will be contributing as both, because for v it is incoming also and it is outgoing also. So in degree may be add hoga or out degree may be add hoga. Okay, it increases both the in degree and the out degree by 1 for that vertex. Is it clear to all? Any doubt in this?
Yes, sir.
Okay.
यानी सर लूप का जो डिग्री होगा वो इन डिग्री भी होगा आउट डिग्री भी.
Yes. Now example. What are the in degrees and out degrees of the vertices A, B, C, D in this graph? You all just calculate, and I will ask. Then you need to tell me. You all just calculate. This is a directed graph first of all.
Yes sir, directed graph.
Every edge
Yes, sir.
has some directions. Okay. So now tell me the degree of in degree of A.
1.
1.
In degree of A is 1. Out degree of A will be
2.
for B it will be in degree is
3,
3,
in
4
degree
in
is
degree.
in degree is
4.
3,
3, sir. 3.
4.
it is 4. 4. How it is 4? Just tell us also.
Okay.
So
D
from
or
A it is coming, from D it is coming, from C it is coming, and one loop at B.
Okay. Is it okay to all? Who
Sir,
those are
from
saying
D
3?
to
Yes sir.
but sir, for the loop, in degree will be 1 only, no?
Yes, it is 1 only. I did 1 only.
Then sir, how it will be?
It is from
And
A.
from A it is coming, from D it is coming, and from C also it is coming. And one from the loop.
Okay, sir, it is
A
merging.
and D are merged. A and D
Okay,
are
sir.
merged.
Done. Any doubt in that now? From D it is also there. D to A. D to B, sorry. D to B.
Yes, sir.
Now,
but,
हाँ, I got it. Arrow एक ही इसलिए आपको confusion हुआ. Okay. Now tell me what is the out degree of this?
2.
2. Good.
2.
So out degree of 2 is good. Very good. So from B to D and B to B itself loop. For D it will be
D in degree 2, sir.
2
in.
in degree or 1 out degree.
Out
very
degree.
good. And for C it is
Out degree 2, in degree 0.
So is it okay to all now?
Yes sir.
Any doubt? Any doubt?
No doubt sir.
Okay.
No, sir.
I am.
Now coming on to the connectivity. Next term that we need to learn is connectivity. So for connectivity, we should know also some terms before that, such as a walk. Walk is a finite alternative sequence of vertices and edges, beginning and ending with the vertex. no edge appears more than once, but vertex may appears more than once in that case. Okay. So again, I am repeating, walk is a finite alternative sequence of vertices. Alternative sequence of vertices and edges means vertex, then edge, then vertex, then edge, and so on. Okay. It should be starting and ending with the vertex only. Vertex may repeat for multiple times, but edge will not be appearing for multiple times. It may be open and close. Open when the starting and the ending vertex for the walk will not same. Okay, but closed when the vertex, starting vertex and ending vertex will be same. Okay, we will take an example. A path is an open walk now. Open walk, if it is an open, then it is a path. Okay, and again in which no vertex will appear more than one. इसमें vertex भी repeat नहीं होना चाहिए. Okay, vertex repeat नहीं होगा. क्यों? क्योंकि यदि starting और ending vertex same हो गए तो vertex repeat हो जाएंगे. And यदि vertex repeat नहीं हो रहे हैं, it means कि ये open walk है. और वो open walk specifically we will call it as a path. And total number of edges in that particular path will be known as its length. Okay. अब यदि closed walk है तो उसको हम circuit बोलते हैं. A path is a circuit if it begins and end with the same vertex. If the starting or ending vertex same है तो it will be a circuit. Okay. So अब इसका example देख लेते हैं. एक minute. Let me, yes. Take this graph only. Okay. We will find out the walk for that particular graph. So try to identify the walk. It could be starting from a vertex. So let us say I am starting with A. So A, then please name them that E1. Say हम इनको नाम दे देते हैं. E2, H1, H2, H3. Is there any parallel edge in that?
Yes, sir.
Yes, sir.
From D to B and B to D.
E4 and E5.
We have given some name to that also. So A is a starting vertex. E1, A to B we have gone. Okay. Then say B. Okay. E1 B. B then E4.
A to B.
B. Then E5. Then again B. Okay. So is it a walk? This is an example of walk actually. So it's an alternative sequence of vertices and edges, starting from a vertex and ending to the vertex also. So A, E1.
E7 also.
Sorry.
But sir,
Can we have
vertex
E7 also? D, B.
Can we have E7 also? Yes, E7 to B again. Then, but we should end with the vertex only. So it should be B also. There should be B also. Okay. Yes or no?
Okay, sir.
Anyone else is asking some question? So it is starting from the vertex A, then E1, then B, then E4, then D, then E5, B, E7, and B. So it's a kind of walk. Okay, so it is a finite alternative sequence of vertices and edges. So यहाँ पर हमने ये देखा कि it's a finite sequence of vertices and edges, alternative vertices and edges. एक vertex एक edge, एक vertex एक edge ऐसा आएगा यहाँ पर. Okay. Then beginning and ending with the vertex. Okay. And no edge will appear more than once. So we will observe also there E4, E1, E4, E5, E7. They are not being repeated. So they are only appears for only once. But vertex may repeat. So here vertices are repeating like B. B vertex repeat हो रहा है यहाँ पर. Okay, 3 बार आया है. So it may possible. So this is an example of walk. Is it okay? Yes or no?
Sir, is it compulsory that we make a big walk over there, or we can make
Sorry?
only? Sir, is it compulsory that we make a complete big walk? Can't we start from A and end at A only?
How it possible?
Sir, like A to B, then B to D, and okay, it is not possible because we are not going from D to A. We are going from A to D. Okay, sir.
Okay. But in undirected graph, it is possible. It could be of 3 only, na? But the conditions are first and start, last or last should be a vertex. Okay, हो सकता है वो, कोई possible, कोई problem नहीं है उसके अंदर. Now tell me, but वो undirected होना चाहिए बेटा, इस graph में नहीं होगा specifically, okay? Like
Okay.
now we are taking that what you are saying is B, say E4, okay, then D, then E5, and then again B. So is it a walk first of all?
Yes, sir. This is a walk.
This is a walk, and this is also a closed walk. Is this a closed walk?
Closed walk. Starting and ending
Yes,
with
sir.
same walk.
Ending and starting vertex are same, but in the first one, starting and ending vertex are different, so it's a open walk. Okay, and a closed walk is also known as path, जिसमें vertex भी repeat नहीं होंगे. Okay. Sorry, open walk is actually a path, but closed will be a circuit.
Circuit.
Circuit. So it's a open walk. Oh, क्या हो रहा है? Closed walk. Okay. And it is also known as a circuit. Circuit क्या होता है बता सकते हो कोई? Why we are calling it as a circuit?
Opening mean starting point and ending point are same, then it is a circuit.
Circuit यदि आप observe करो तो आपके इलेक्ट्रॉनिक्स
हमेशा closed ही होता है.
क्या?
Circuit is always closed.
Yes.
Sir, ये closed हो रहा है ना.
If you observe and take an example of electronics lab, so circuit should also be always be closed. जब तक वो closed नहीं होगा तो circuit बनेगा ही नहीं वो.
Yes
Lights
sir,
on.
circuit बनेगा ही नहीं.
So that's why it is also, you can compare, you can like correlate it with that way and you can remember it. Okay, so closed walk will always known as circuit, and if it is an open, then it is known as a path. But in path, be careful that no vertex should be repeated. So is it okay now? All these terms have been okay. What is a walk, path, and circuit? Now tell me what could be the length of that particular path. For first path, what could be the length of this?
2.
4.
Read the definition of that particular length and then tell me what would be the length of that path. Okay, number of edges in the path is called the length. So how many number of edges are there in that? In first one,
4.
4, and the
Four.
second one,
2.
2.
2.
2. Second one is 2. So this is what the path of circuit and that one, and based on that the connectivity we can find out. Okay, the in undirected graph is called connected if there is a path between every pair of distinct vertices in the graph. Now the path could also be in the undirected graph. अब आप ये मत सोचिए कि it could always be these terms will always be for only be directed graph. Walk, path, closed path, circuit, open path will always there for the undirected graph also. Same, in same manner. Okay. Now for undirected graph, the connected, if it is following the following properties, it means if there is a path between every pair of different vertices in the graph, then that particular graph is called connected vertices. It means कि हर vertex किसी न किसी तरीके से दूसरे vertex से connected होना चाहिए, reachable होना चाहिए. You can say that, reachable. Okay. I am not saying कि directly there should be a path. Please underline that thing. There should not be a direct path also. There may be a undirected path. Undirected path मतलब via path भी हो सकता है. हम कहते हैं ना कि like there is no direct flight from Jaipur to Bombay, है ना? So it is from first I need to go to Delhi, then I need to move to Bombay. So it's a via path. So similarly here it is also possible. There may be a connection between every vertex, but it should be not directed. Okay. So for example,
we will have a via path, but indirectly there is a direct connection between some. There has to be a direct connection between two vertices.
Very good, very good. Direct, not direct connection. Indirect connection could also work in that case.
मिडिल में कोई है, इसका मतलब मिडिल में कोई
डायरेक्ट भी हो सकता है, इनडायरेक्ट भी हो सकता है, दोनों चीजें हो सकती हैं, बस कनेक्टेड होनी चाहिए दोनों चीजें. ओके, लाइक कंप्यूटर लैन में जब हम बात करते हैं, सो इन योर लैब, कंप्यूटर लैब्स, व्हाट हैपेंस एक्चुअली, ऑल द कंप्यूटर्स आर नॉट डायरेक्टली कनेक्टेड टू ईच अदर, बट दे आर कनेक्टेड टू ईच अदर. Yes or no?
Yes, sir.
I have taken an example of that also in the last class. A graph consisting of only one vertex is always known as connected graph because it does not contain any pair of distinct vertices. So this is a particular note that you have you need to keep in your mind because ये पूछा जाता है कई बार MCQs में. Okay, a pendant vertex, isolated vertex is a connected or not? ऐसे क्वेश्चन पूछे जाते हैं. Okay, now अब मुझे बताइए, is this a connected graph?
Yes sir, but not directive.
Is it a connected graph? Is every vertex is reachable from every other vertex?
Yes sir, connected है.
You observe that from A can I reach every other vertex, whether it may be direct or not direct?
Yes, sir.
Yes, sir.
Yes sir.
Yes, sir.
Similarly for B, similarly for C, D, E,
For every vertex.
all the vertices are reachable to every other vertex. This is a connected graph. Okay, now tell me, is this a connected graph?
No, sir.
No, sir.
sir.
No, definitely we can say because from B to A we are not having any edge, direct or indirect.
सर ये दोनों अलग अलग ग्राफ है या एक ही ग्राफ है?
ये एक ही ग्राफ है बेटा.
अच्छा, तो ये कनेक्टेड नहीं है एक दूसरे.
Is this a directed graph?
No, sir.
नो सर.
Why not?
सर डायरेक्टेड है क्योंकि हम अगर
Sir,
ई से
there's no
चले तो
connection between D and E.
नहीं, ऐसी बात नहीं है, कोई बाईपास तो भी है.
Go to A to E.
जैसे ए से ई, वो ई से ए से डी, डी से बी और बी से सी. तो हम सी पर पहुंचना है, जैसे तो हम ए से बी भी ले सकते हैं, पर डायरेक्ट कनेक्टेड नहीं है ई और सी से, लेकिन ये डायरेक्टिव ग्राफ है.
Is this a connected graph?
Yes, sir.
यस सर.
This is a connected graph because we can reach from any vertex to any other vertex.
यस सर.
Is it okay to all now?
ओके सर.
Who says that no, it is not a direct connected graph? Is it clear to
Yes,
him
sir.
or her now?
सर मुझे
Now
clear
tell
है,
me,
सर.
tell me, is this a connected graph?
No, sir.
No, sir, this is just overlapping. It's not a connected graph.
Very good. It is not a connected graph.
ओवरलैप है ये.
So, is it okay now? What is connected and disconnected graph? Now connectivity. Okay, one more term is there with the connectivity. That is a graph that is not connected in the union of two or more connected subgraphs. Okay, like in this way, the graph number 2 and graph number 4, they have two different components, but they are not, the whole graph is not connected graph, but the two parts it has, they are individually connected. Yes or no?
Yes,
Suppose
sir.
if in
Yes,
this particular graph, second graph, suppose I am saying ki, this whole graph is actually not connected graph because we don't have any edge or connection between A and B. Okay, direct connection or indirect, whatever it is, but it has two parts. One is BCD, which is connected, and second one is AE, which is connected graph. So in this particular disconnected graph, we can say that it has two connected components. Okay, that is what we are trying to learn now. So union of two or more connected subgraphs, each pair of which has no vertex in common. अब इन दोनों में कुछ common भी नहीं है, definitely. Okay, and these disjoint connected subgraphs are called connected components of the graph. So is it okay now? Any doubt in that particular definition? So if you see in that, we can say that B, C, D is one component, and A and E is one component. Both are subgraph also of the whole graph. Yes or no? Subgraph का मतलब समझ में आता है आपको? Subset.
Yes sir. B and C is the subset of BCD.
So these are two different connected components of the graph. But be careful, there should be no common vertex in that. Okay, now like in that, if I am asking, is B, C, D and D, A, E, R connected components of this graph?
No, sir.
Why not?
As B is common.
Very good. So it should not be common. No common thing should be there actually. Okay, so they are not connected components, but they are connected components. So I think it is clear now. Now next thing is, what are the connected
Sir, can you
components?
repeat it? Can you repeat it?
Yes, we have seen the condition that for the connected components, no common vertex should be there. Like यहाँ पर B, C, D and AE, there is no common vertex. But in this, D is common. So I am saying they are not connected components. Okay.
Okay, sir.
Now look at that. What are the connected components in the following graph? Can anybody tell me? How many connected components of this particular graph you can say?
A and D.
How many connected components are there in this following graph? How many? First of all, tell me the numbers and then tell me the like connected components.
Sir, 2.
4, sir. 4.
2 connected components are there. Someone is saying 4 components are there.
2.
2 कुछ बोल रहे हैं.
This complete is a one graph only.
This is a whole graph. This is a single graph actually. क्या ये ग्राफ है first of all?
ग्राफ तो है बट कनेक्टेड नहीं है अभी एक दूसरे से.
Connected graph है, but it is not. But it is disconnected graph. Now tell me, is the 2 components are there or 4 components are there? We have just seen the components.
I think 4 है.
I am giving you the example of that. In this 2 components are there. So how many components are there in this graph? Connected components. We also seen that I am getting you where you are getting confused. Please read the node. A graph consisting of only one vertex, always connected, because it is not having distinct vertices. At that point, you may have doubts on. So there are actually 4 different components of this graph. First is ABCD. Second one is E only. The third one is F only, and next one is F, H, G, I, J. There are 4 different components of this graph, and they are connected also. Yes or no? Is it okay?
Yes, sir.
Yes, sir.
Okay, sir.
F is also a component of that graph, which is connected because it is a single vertex. There is no edge. Okay?
Isolated.
Similarly, E is also a connected component. Now,
Sir, why FGH
F,
is
G,
a
H,
connected
J.
component?
F, G, H, J is the connected component. Acha. Is this graph, suppose you take this as an individual graph. Okay. Is this a connected graph? Can I reach from one vertex to
Yes, sir.
every
It
other
is
vertex?
connected graph.
Connected.
Yes, sir.
So that is a connected component.
You are taken 2F. One is isolated and other is connected through each other elements.
Divyanshi, it is okay to you? Why it is connected component?
Sir, I'm getting confused now.
Why? You just ask now why you are silent. F is repeated. Please ignore it. It could be anything else. It could be X. Okay. What is the confusion?
So for to be a connected component, is it necessary that the graph should be closed?
No. A, B, C, D is not a closed graph. It is, but it is connected. In this example, you are seeing that. Can I reach A to A from any other vertex, B, C, D?
Yes, sir.
Can I reach B to any other vertex from A, B, D, A, D, C? Can I reach to B?
Yes, sir.
Same for C and D is not there or not?
Yes, sir.
Same.
So that is what the connected component, connected graph means. If I am able to reach from a vertex to every other vertex or vice versa to a vertex from any other vertex, then it is a connected graph. तो आप F, H, G, I, J में देखें, क्या हम F से तीनों वर्टेक्स से पहुंच सकते हैं H, J और G पे?
Yes, sir.
Similarly, for every other vertex, it is true. That's why it is connected component.
सर
connected
इसका
graph.
एक एग्जांपल दो सर।
But इस example में देखिए आप B, C, D and AE. From B, I am not able to reach at A. That's why it is disconnected graph.
Disconnected.
And
As soon
so
as
each individual component of a connected graph is a connected component.
disconnected graph, each individual component of disconnected graph, which are also to be connected actually. Individual component भी तो connected होने चाहिए तभी उसको हम connected component बोलेंगे,
Okay, sir.
है ना? Like अब जैसे इस second graph में यदि मैंने एक edge डाली यहाँ से A से B में, तो अब ये connected हो गया automatically. Okay, अब I can reach from A to any other vertex, I can reach from B to any other vertex and so on. Done?
Yes, sir.
सर इसका एक एग्जांपल दो।
हाँ बिल्कुल।
जैसे मैं सर मेरा होम जो डिस्ट्रिक्ट है धौलपुर, तो मैं धौलपुर से सर आगरा भी जा सकता हूँ, धौलपुर से जयपुर भी जा सकता हूँ। तो कहीं सिंपली वर्ड में कहेंगे कि धौलपुर कनेक्टेड टू जयपुर एंड आगरा आल्सो, बिकॉज वी रीच जयपुर एंड आगरा both through Dholpur.
Very good.
It is a connectivity.
So we are moving ahead now. So connectivity now. Connectivity. Now again a directed graph. Now in the case of direction now, directed graph is strongly connected if there is a path from A to B and from B to A, whenever A and B are the vertices in the graph. So simple connectivity is something else, but strongly connectivity means we should have the connectivity from A to B as well as from B to A in direction. This is in the case of direction only, okay? Because in the case of undirected graph, ये तो होना ही है हमेशा. यदि एक ही edge है A to B में तो दोनों तरफ माना जाता है उसको. But you are getting my point. What I want to say? Suppose U and V is there, okay, and I am having this particular edge, undirected edge. So there is an edge between from U to V and V to U both. It will be considered as both. But in the case of direction, in the case of direction, I can say only that there is an edge from V to U to V only.
So sir, for strongly connected, we need a parallel graph. Parallel edges.
No. It is not required actually parallel graph. Now let me explain that. U, V, W, say one is the vertex. So this could also be a strongly connected graph. From U to V there is a path, and from V to U there is also a path. I am seeing a path.
V is connected to U through W.
Not directly connected. It is not actually required. If there is a path, we are seeing a path.
Yes.
You know, there is a path. So from V to U, there is a path or not? V, W, U. There is a path. So that is what the strongly connected graph. Is it okay now?
So sir, if there is a parallel edge we say, then is it also strongly connected or we call it something else?
No. It could be a strongly connected. You are saying that thing. This is also a strongly connection. No issue. A path could have only one edge. Beta. ये भी मैंने बताया ना अभी. From U to V there is a path. Like we can say, suppose this is an edge E1. Okay. And E2. So U, E2, V is a path, V, E1, U is a path. Both are path. Or even we can say that E3 suppose it is, and it is suppose E4. So that V, E3, W, E4 and U is also a path. You have got it now? And otherwise the graph is called weakly connected. Okay? A directed graph is a weakly connected if there is a path between any two vertices in the underlying undirected graph. So now example. Is this a weakly connected or strongly connected?
Weakly connected.
Exam answer देख लिया है. Now tell me, you can understand with the help of that, because for the example, like we are not having a path from B to D in that case.
डायरेक्ट पाथ नहीं है.
B की डायरेक्ट पाथ होना जरूरी नहीं है बेटा, अभी तो मैं समझा के आया हूँ पीछे. Weakly connected graph, it means I am having a edge from D to B, and there is a path from D to B. ओके, D से B पर एक पाथ जरूर है, यहाँ पर दिख रहा है हमको ये वाला पाथ, लेकिन B से D पर जाने के लिए कोई पाथ ही नहीं है.
So sir, there is no path from A to D also.
हाँ, actually you can observe that D for D in degree is
0.
So we are not able to reach to D anymore. किसी भी तरीके से हम D पे तो पहुंच नहीं सकते. So that is the graph which is weakly connected.
अच्छा सर, टू वे
यदि किसी भी ग्राफ में एक वर्टेक्स,
चाहिए.
यदि किसी भी ग्राफ के एक वर्टेक्स की डिग्री इन डिग्री 0 हो जाती है, so we are, or we can say if we are not reachable to any other vertex, so it will be a weakly connected graph.
So
Sir,
to
we
not have a weakly connected, each vertex should have at least one in degree.
No, मतलब वो एक, मतलब मैं बेटा इसका उल्टा बोल रहा हूँ. यदि है ना, यदि किसी भी वर्टेक्स की इन डिग्री 0 हो जाती है, तो श्योर है कि वो ग्राफ वीकली कनेक्टेड होगा ही होगा. लेकिन यदि इन डिग्री 0 नहीं है, तो ये श्योर नहीं है कि वो वीकली कनेक्टेड होगा या नहीं होगा. जस्ट सॉल्व कनेक्टेड होगा ही होगा.
Yes sir, to not become a weakly connected.
हाँ. So if the condition is only one sided, it is only one sided condition. If the in degree is 0 of any of the vertex, then it is weakly connected surely, but vice versa is not true. Okay, वो तो एक केस है स्पेसिफिक बच्चे कि हम ऐसा बोल रहे हैं. Now tell me, is it a strongly connected or weak?
Hello.
Yes.
Sir, it is compulsory for make strongly connected graph to two-way, because a degree is 1. Compulsory it is.
क्या कह रहे हैं आप? I am not getting you actually.
सर मैं ये कह रहा हूँ कि अगर हमको स्ट्रांगली कनेक्टेड ग्राफ क्रिएट करना है, तो उसके लिए कम से कम एक 0 वो एक तो 0 डिग्री होनी चाहिए और एक 1 डिग्री होनी चाहिए किसी वर्टेक्स की. ये कंपलसरी है सर.
ये किसने बोला आपसे?
किसी ने भी नहीं सर. कुछ डाउट था तो आ गया सर, पूछ लिया.
बच्चे अभी तो अपन पढ़ रहे हैं कि ऐसा नहीं है. ये दैट एग्जांपल आई एम शोइंग यू ना, इन व्हिच द डिग्री इज 0 और इट कुड बी 1 आल्सो.
हाँ बताया था सर अजय को.
तो फिर सबको मैं अलग ही, मतलब आपको क्या समझ में नहीं आया बेटा? मुझे समझ में नहीं आया. अभी पूछना क्या चाह रहे हो आप? मुझे ही नहीं पता लगा.
सर मुझे ये पूछना था कि हमको स्ट्रांगली कनेक्टेड ग्राफ बनाने के लिए किसी वर्टेक्स की एक डिग्री तो 0 होनी चाहिए, इन डिग्री और आउट डिग्री दोनों होनी चाहिए ना सर?
नहीं समझ में आ रहा बेटा मुझको, आप क्या कह रहे हो?
चलो सर, कुछ नहीं.
Strongly connected graph. This is a strongly connected graph.
Yes,
Because
sir,
we
yes.
have, because it is possible to have a path between every pair of vertex. Okay.
सर ये सर यही बोल रहा था मैं.
Special graph or complete graph. This is a special graph of a connected graph actually. अभी हमने देखा कि if there is a path between two vertices, then it is a connected graph. Path. We are talking about a path. Okay. Now I am telling you that if there is an edge between every pair of vertices, so there is a difference between a path and an edge. A path may contain multiple vertices, multiple edges, but if I am talking about there is an edge between every pair of vertices, it means there is now a direct connection between every pair of vertices. Direct connection की बात कर रहे हैं हम लोग. Okay. Then in that case, that particular graph is known as complete graph. Okay. Likewise, and we will represent that particular graph as Kn, where n is the number of vertices. Why it is not showing in that slide? Now it is showing. So first of all, is this a connected graph?
Yes, sir.
Yes
So
sir.
it will also be a complete graph. Okay, for K2 it means 2 vertices with complete graph. क्या होगा वो? 2 vertices होंगे और उन दोनों के बीच में एक edge होगी. So
Line.
direct edge is there. Okay, now K3 it will be a triangle. So every pair of vertex has a direct edge in between them. Is it okay? For 4, every
Square
pair
with
of
diagonal.
vertices have a direct edge or direct connection in between. Okay. Similarly for K5, it will be with the 5 vertex graph where every vertex has a direct connection between every other vertex. Is it okay now?
Should be directed or not?
No, it could be directed also, but these are undirected. But in the case of direction, the number of edges will increase now. So first of all, is this all understood to all? What does mean the complete graph? So tell me now, is this a complete graph?
No, sir.
No, sir, because
Is this a
there are
connected
no-
graph?
Yes, it is connected.
Yes, sir.
It is a connected graph, but it is not a complete graph.
Very good. So it is a connected graph, but it is not a complete graph. So इससे हमें ये भी समझ में आता है कि like suppose I am having a connected graph. So connected graph and complete graph दो चीजें हैं हमारे पास. So यदि graph, if the graph is connected, so क्या वो compulsorily complete भी होगा?
No.
No.
No, sir.
No, sir.
But if it is a complete graph, तो क्या
Complete
वो
graph, it is compulsory
Then it will be connected.
Yes.
connected.
Is it okay to you all now? Now look at that. If
Yes,
the direction we will look. So direction के केस में क्या होगा? It will K1 remains as it is, but K2 will be look like this. So one direction and one then this way. For K3, it will be like one direction, and similarly we should have that kind of connection. Is it okay
It
now?
can be connected also, na? We can say that if we provide vertex name A, B, C, then they can be directly connected to each other.
Yes.
So why we are
Connected.
making parallel edges? It's not.
To make it complete graph. Right now I am directly connected from A to B, but there is no direction. No, if I will not have this particular edge, then there will not be a direct connection from B to A. So to have a direct
Reverse
connection between,
Okay. Reverse connection.
है ना? If we want to have a direct connection from every pair of vertices, then it should be a complete graph only. So to make it a complete, we should have like this, this kind of a structure.
So sir, can we have a direct connection with self also, self vertex from A to A means?
Sorry.
Yes, it is. It may be possible.
Sir, can we have a direct connection means for complete tree, complete graph? Sorry, a loop connection. We say A to A connection.
No. We could not. It is not required. It is only a complete graph also. But suppose you are having this one, so it is an extra edge, but it is a complete graph. So minimum requirement is that one only. Okay, you should have a connection from every vertex to every other vertex, direct connection. यदि ये है तो ये extra है. It doesn't like, but it will not affect the definition. It remains complete graph also. Still in that case, I am having a direct connection between every pair of vertices. But A to A is not required in that case. Is it okay?
So I have a doubt that one vertex
Sir, a loop is a connect.
include itself edge. Then it called complete graph.
बच्चे ये लिखा हुआ है ना यहाँ K1 is a complete graph.
सर इसमें लूप इंक्लूड नहीं है ना.
वही तो मैंने बोला लूप डालोगे तो कोई फर्क नहीं पड़ेगा. अभी जस्ट आई हैव टोल्ड यू कि इन दिस इफ आई हैव पुटिंग अ लूप देन इट विल नॉट अफेक्ट द डेफिनेशन ऑफ कंप्लीट ग्राफ. So in any graph you will put a loop, then it will not affect the definition of complete graph. But now it will not be a K1, K2, K3, K4, K5. एक चीज ये भी ध्यान रखिएगा आप लोग, K1 is only this single vertex. Loop will not be there. K1, K2, K3, K5 यदि क्वेश्चन में आता है आपके पास, तो आपको केवल यही बनाना है, आप लोगों को लूप इंक्लूड नहीं करना है। तो ये एक सम स्पेशल ग्राफ्स हैं, ऊपर हेडिंग भी लगाया है मैंने यहाँ पर, स्पेशल ग्राफ। सो दिस विल नॉट बी a K3, ये K3 नहीं है। You are getting it all of you. K3 is only that, and in the case of direction, K3 will only have that in which a loop is not there. You are getting it now?
Yes, sir.
So we are not counting loop as a complete graph, that means.
For K3, we are not counting as a loop. Loop will not considered like in that K3.
No, sir, I am asking in general. We are counting loop as a complete graph or not?
No. For loop, like there is a connection from the one pair of edges, vertices, A to B, B to C, and A to C. A to A is like not required to be a complete graph.
Okay, sir.
है ना? Loop will not require to be a complete graph. It will be an additional part also. I am saying again, but in that case, the graph will also remains complete graph, but it is not necessarily condition for graph to be a complete. अब ये वापस रिपीट कर रहा हूं मैं, K3 is only this one. Please remember that K3 में लूप नहीं होंगे, K4 में लूप नहीं होंगे, K5 में लूप नहीं होंगे, K10 में लूप नहीं होंगे. Okay, because there are some special graphs in which I have a specific structure. ये specific structure है K5 का with undirected edges. With directed edges, it will have double edges, just double edges with the directions. Okay. So what is the time actually? I'm not.
10:56.
It's 10:56. So some special graphs also we should learn, like cycle, wheel. So we will continue tomorrow now. Okay. Till now, if you have any doubt, you can learn. You can ask now. These basic terms are very much important actually, because of the two reasons. They may be asked in the 2 marks questions in your RTO or midterm examinations, as well as they definitely will be asked in MCQs whenever you are going to appear in some competitive examinations, or like some we can say
GRE में आएगा सर ये?
company examinations. So it is GRE भी competitive exam ही, यदि ग्राफ उसमें होगा तो आएगा जरूर.
Okay, sir. So I have a doubt in binary search deletion part, sir. Second case.
Right now, I am not talking about that thing. I am talking about graph only.
नहीं सर, वो उसके ग्राफ के खत्म होने के बाद सर पूछ सकता हूँ? ये कर रहा हूँ, ये पूछ रहा हूँ.
हाँ जी, बिल्कुल. So let me take the attendance first. If you have any doubt in this graph, you can ask me on now. So I have shared that PPT already with you all. So you should gone through the slides, and if you have any doubt, you can ask me. Okay, ये पूरी PPT आपसे already share कर दी है मैंने.
Yes, sir. Lecture number 62.
So that is all for today now for graph. I am closing the meeting now. Thank you very much.